I want to talk to you today about some recent experiences of mine, and I get the feeling this topic may rear its head a few times over the next few months, maybe even the next few episodes, because it's something I've been thinking about a lot recently. Like many of my age and my generation, and I will be 35 in a few weeks, I started learning to program with BASIC. These were the days, and they were quite a while ago, when you bought magazines full of pages and pages of code for games and basic applications. You then spent hours and bored school holiday afternoons typing these into a computer with your friends. I think for me it was either a Commodore 64 or a Spectrum or something like that. I think it was a Commodore 64. Typing them in page after page, getting to the end, running it and finding that what you'd actually put in didn't work. And whether it was you'd mistyped something or there was a typo or who knows, but by that point, being young kids, you'd kind of just given up a bit. I remember once actually doing one with a waiter trying to catch a turkey, and the turkey never moved. So it was a rather boring game. But I think it was more about hanging out with your friends, really, and your parents felt like you were learning something, so it was an activity that they were happy to support. And of course, BASIC as a language had its flaws. But one thing I kind of liked about it and still like about it was that it's actually very clear what's going on. There's no grey areas, there's no abstraction about what's going on. And this is why programs took ages to do anything, I guess. I mean, there's little chance of any language being released now having any syntax like BASIC, like with line numbers, mandatory line numbers, and the kind of classic go-to line number, things like that. I don't think anything they would want to write anymore would work with languages like that. But still, I guess my point is, it was very clear what was happening. And this is kind of the point of what I want to discuss. Years later at university, and I was always playing around with computers, but more kind of multimedia authoring than coding. I think I might have dabbled a little with some things, but most of my programming, well, not really programming experience, but coding experience actually came from HTML and then wanting to do more with that. So I started learning more modern programming languages via, I learned PHP quite a lot. I learned Lingo, which was the scripting language of Macromedia Director, and became kind of the more advanced ActionScript in latter versions of Adobe Flash. I learned some C++, I learned some Visual Basic, and I learned some very early days of Java. I can't quite remember if we covered object-oriented programming or not, but we must have done. I think I just remember most of it being procedural. But it's amazing how quickly you forget, to be honest with you. I guess then spending a lot of time working with Drupal, which I did for quite a while, which is not really object-oriented until version 8. Probably didn't help that I missed a lot of those concepts for a few years. So come forward to the present and why I sort of wanted to talk about this post. So the past few months, I've been teaching programming to recent Syrian refugees. Who they are, where they come from is not necessarily the relevant part of this discussion, but what I want to highlight is they're, for the most part, complete beginners. They've never programmed before. And it also reminded me of a time many years ago when I taught computing for beginners to elderly people, again to some recent refugees and other people who've never touched a computer before. And this was also an eye-opening experience. And actually I would recommend teaching complete beginners, people who've never been exposed to something, because it really opens up your mind. One of my memories from this Computing for Beginners class was that someone picked up a mouse and waved it around in the air, and people laughed. But actually, why does moving a mouse around on a flat surface at a 90-degree angle to the computer make any more sense? So, sometimes these things get opened up to you. But fast forwarding back to the present, jumping around a bit here. So the school decided to teach Ruby and part of that Rails. Now, I don't want to turn this into a Ruby or Rails bash. It's not really what this is about at all, actually. It's more about teaching to beginners than having a go at a particular language. Because actually I quite like Ruby and I quite like Rails. But as the teachers, we're wondering if it was a good choice. I guess some of the reasons for picking it in the first place is for experienced programmers. It's a fairly straightforward, elegant, nice language. Of course, it's experiencing some kind of downturn in popularity now, but that's more a consequence of programmers getting bored with things very easily and liking the new and the shiny more than anything being completely wrong with it, for it to be pragmatic about the topic. But also, I guess, the Ruby community and the Rails community has been a very supportive community. It's been a very good community for welcoming beginners in and helping them. And this is maybe one of the main reasons to think about teaching it. There may be some better languages to teach to beginners, but if the communities suck, then they're going to put beginners off. And these were some of our reasons for doing it. And then I guess I should admit that maybe some of the problems we've come across have been more about teaching the wrong things in the wrong order and not being completely strong on what we wanted to say to people, and what we wanted to say to people when and why and things like that. But again, I guess this brings things back to what I'd really like to discuss, which is not bashing Ruby, but the best way and the best languages to teach beginners. So some of the things that we noticed about Ruby in particular that has attracted experienced programmers are actually fairly confusing and difficult abstract concepts for beginners to understand. So some very brief examples of this are things like shortcut tools. So we often know that a lot of programmers can be a little bit lazy. And I guess I should rephrase what I mean by lazy. I mean in terms of there's a lot of boilerplate code in some projects that is a bit pointless retyping every time. So actually we have frameworks, we have tools, we have things like that that generate a lot of that boilerplate code for us because we know what it is, we've been there, we've done it, we've written it 100 times, we don't need to write it 101st time. So we have a tendency to teach people to use these tools. So for example, with Rails, it's scaffolding. With one very simple command, you can create the entire basic underpinnings of an application. And while sometimes we may forget, we have a rough idea of what goes where and what has been generated and why it's useful to us. But to a beginner, just saying, enter this command and it creates XYZ for you is actually super confusing. Not really sure what it's created, why, and why they should not care about it, I suppose. We're telling them, oh, don't worry about it, this is just the default thing that happens. But that's a confusing statement to a beginner when you want to understand everything and the reasons why behind everything. Someone telling you, oh, don't worry about it, is actually super confusing and contradictory. So I guess one of the issues I'm getting at with this is this abstraction, this layering on of abstractions over languages. A common argument that programmers will make is, oh, let's make this simpler, let's use a framework to do 50% of the work for us. Let's add another plugin, a gem, a module or whatever to replace this functionality for us. And as we know what it's replacing, we've walked before we can run, we understand the efforts that we're cutting out. But to a beginner, is this helpful? We've cut out a lot of things without ever really explaining why we're cutting them out and without them ever really understanding the years of pain, in inverted commas, that we've been through to want to cut them out. And I think that's something you have to be careful of. Sometimes maybe we need to take the long approach to programming and not just jump straight to the practical shortcuts that we might take on a day-to-day basis. Maybe actually beginners need to learn the pain first before they can appreciate why we take that pain away, maybe. I'd also like to maybe cover some of this kind of shortcut syntax. So it's hard to maybe describe code in a podcast, but for example, Ruby has this concept of if you want to iterate over 100 numbers and print the value of each number, instead of the kind of horrible, although I actually quite like it, for loop with like I is equal to 0, when I is less than 100, iterate on I, and then inside the loop print I. I mean, it's ugly to look at, but actually I don't mind it. Ruby has this notion of we can just have brackets 0 ... 100 ... each. For each item in that range, print the value. This isn't necessarily the best example I could pick of, but it's just one that came into my mind. Because looking at it, it's very elegant to look at. It's very simple to look at. And anyone who kind of is used to programming flow understands what's going on. But maybe to a beginner, it's like, what is this? What's happening? What do these dots mean? There's no kind of relation to a word in the English language, for example, that makes any sense. And I guess this is another thing to be wary of, is that sometimes the syntax that an experienced person finds incredible actually hides a lot of the complexity, which is why we like it. But hiding that complexity means it's not explained. And sometimes the long form way of writing code is actually better when educating. There's another interesting thing I'd like to talk about, and this is also moving on to a changing trend as well. There was this trend over the past few years of these sort of do-what-you-like languages. Languages were infinitely flexible. You didn't have to worry about typing your variables. You didn't have to worry about this. You didn't have to worry about that. You could leave off semicolons. You didn't have to worry about white space and all these sorts of things. And whilst they made programming quite quick, we got to a point where we realized that the potential problems caused by this flexibility were maybe outweighing the convenience. And there has been a trend now, and I've noticed this in my very, very, very brief exposure to functional languages, that actually forcing, and also like type-safe languages, of forcing programmers to act a certain way. You must declare the variable. You must check for this. You must check for that. And this is a good thing in some respects. And actually, I wonder if those sorts of languages, unfortunately, they're often designed for more advanced programmers who solve more advanced problems. But in some ways, they're better to learn because there is nothing implied. Everything is obvious and clear. This is a string variable, not this is a variable that might be a string. Again, to a beginner, this is a variable that might be a string is a little hard to understand. This is a string is actually quite easy to understand. So this is an interesting trend that may be changing, but some of those languages from the previous years may be actually causing difficulty to beginners. Okay, this is getting a little bit out of the programming world, and maybe this is just a topic I have on my mind, and it's not the best place to speak about it, but it's my podcast, so here we go. This sort of subject of constantly wanting to make sure we're educating students on the real world of work and take-homes, nugget-sized bits that a student can take home, and the deliverables and outcomes and things like that. And a lot of this may be just that programming has become the cool thing to do, and the marketing departments have taken over running of these programs, and et cetera, et cetera. But it is a little concerning sometimes. There's such a focus on trying to get students into jobs, neglecting the fact that just because you've spent 2 months learning to code doesn't mean you're going to get a job. A lot of coding actually comes from experience of applying knowledge that you have and relating to situations that have happened in the past, not just having done an intensive course. And that can't always be taught. So I worry a little bit about this, but that's maybe a whole other topic of discussion. I guess some very specific things I would like to cover here. Something like, for example, object-oriented programming. We obviously know it's not that complex a topic, and it's not even that new a topic, but it's one that we should teach, and sometimes trying to teach it to beginners is maybe handled too soon. We've just covered things like variables and flow and logic, and then suddenly everything changes and we're talking about objects. And conceptually, actually, they can be really simple. But in understanding how they're actually going to practically be used is maybe harder to understand. It's like this strange middle ground. Explaining the basic concepts of inheritance and instances and things like that is actually reasonably straightforward. And then seeing where an object and a class will be super useful in an advanced program is also clear. But that kind of bit in the middle, where beginners are going from point A to point B, is actually sometimes super hard to explain when objects are going to be useful, because often they're not even being used. So you sort of explain to someone a concept and then don't really use them for a while. So yeah, it's one that maybe even it should be left for a while. Or yeah, it's one I'm struggling to answer the question to, but it's something that it can be confusing. And this brings me on to another sort of similar topic, which is version control. So we all understand that in a more realistic, distributed, multiple people software project, version control is a godsend. It's an amazing way of collaborating, of merging work, of rolling back work, and a whole myriad of other things that we can do based on version control. So we understand why it makes perfect sense. But to begin with, there's a couple of problems with it. Firstly, some of the concepts with it can seem like an unnecessary complication. We've been teaching students version control and constantly have to remind them to keep checking things in and out, because the longer you leave it, the harder it gets to sort of merge things in. And they're slowly starting to see why it can be valuable, but at the moment it seems more of an inconvenience than a useful tool. They're using it because we're telling them they should, not because they necessarily understand why they should. Maybe there's a little bit of a fear thing. This has always been an aspect of teaching computing that has been something I've tried to be careful about teaching well. And that is a concept that lots of people still, even now, feel like they don't understand computers. They shouldn't understand computers. They're not for them. They can break something. And maybe when you're programming on your own little sandbox, the only thing you're going to break is your own stuff. But if you start collaborating with people, you stand a chance of ruining their work as well. And yes, sure, sometimes it can happen. But actually, for the most part, especially with version control, it's generally relatively easy to get things back again to at least some sort of salvageable state. So I think it's an aspect of teaching that control that you have with it. But again, it's a tough one. And especially the Git workflow, there's lots of little steps that sometimes you've made a small change, and then committing that change can be almost as much work as the change itself. And some of the visual tools help with that, but that again is maybe a layer of confusion that see previous discussion. So this is all well and good. What do I suggest? So here's a few bits of advice that I've picked up myself. And what I really want to do at the end of this, I want to encourage some of you to contact me and tell me what languages and techniques you've also found useful. That's what I'd really like to know. And I'd like to sort of crowdsource a sequel to this post based on some of that feedback. So my first tip would be assume nothing. You might have heard this before, but I want you to try taking it to a stage further. Here's a little soundbite for you that you can quote to me. If you assume nothing, then there's nothing to lose. Okay, you may lose a little bit of time, but not that much. In practice, this means that you shouldn't assume anyone that you're teaching has heard of your favorite build system, your favorite language, your favorite idea, your favorite editor, your favorite whatever, or assume that anyone has the same experiences as you. Just because you think they should have, it doesn't mean they have. Of course, if you check and ask first, go ahead. But check first. Don't just assume. And I think this helps a lot. And so you might end up duplicating a little bit of content to some people who've heard it already. But I genuinely think that most people aren't too bothered about that and are patient enough. And again, hearing something for the third time might mean they understand an issue better than they thought they did, or pick up something they hadn't thought about before. Context. This is a big one for me. I often found with presentations from coders and programmers that we're very good at explaining that something is cool, that something has feature X, feature Y is 100% better at performance, at stability, etc., but not necessarily good at explaining why this is a good thing. So when educating people, we shouldn't just mention what it can do faster, better, bigger than before, but also why this is good for them. Maybe even in some respects, sometimes thinking like a business person. And a beginner coder can be thought of someone who still some way needs to be sold on what they're doing. So explain why this is easier, why this is better, why this is useful, practical outcomes of this. This plugin helps you accomplish a checkout shopping cart quicker than doing it this way. This plugin lets you not have to worry about authentication. These are some very simple examples, but things like that. Try to explain why something is useful to know, to learn. Then we also should think about the community around languages. And I've already mentioned that Ruby and Rails is a very good and supportive community, Python as well, and there are some other languages that do very well on community. And specifically communities that try hard to nurture beginners, that really stick at it, that are really patient at helping people understand and give beginners lots and lots of opportunities. So it's important to bear this in mind, that be patient with beginners, have a community and nurture a community that treats them nicely and doesn't just tell them to read the fucking manual or stop asking stupid questions and things like that. Okay, there are better ways sometimes to ask questions. Some people ask questions in a very unhelpful way, but there are helpful ways to answer those questions as well. And yes, I know I have been there myself. Sometimes it gets frustrating dealing with these questions that to you just seem really inane. But try hard. I do completely understand. I have done the same things myself sometimes, of being maybe blunter to someone than I should have been. But continue to support those communities and don't dismiss the community efforts that the communities around your language try. Just because someone is a better community wrangler than a programmer doesn't mean you should look down on them. Respect your organisers, respect your community heads as well. They may not do technical work, in inverted commas, but they do important work and they do hard work. Figuring out a piece of code is hard work, but so are people. People are hard to deal with. They have emotions and feelings, and they're irregular and unpredictable and inconsistent and unreliable, and trying to manage a group of people is hard work. Trust me. So respect the people who try. That's enough of all that. What I'd like to get down to, as I say, is I'd love to know some of the best programming languages you think to learn. What are the best ones to learn? How are they best taught? What's the best order to learn programming in? This sort of advice I'd love to hear from you. When you submit this advice, I'd like you to think from the perspective of a beginner. Don't just say, well, I did this and it was good enough for me. Think back. Assume nothing. Think back to a time when you knew nothing. You didn't even know what a variable was. Would this make sense to someone who didn't understand that? Would this really be the best approach? So I'd love to hear from you. You can post some comments in the SoundCloud feed. You can post some comments on the iTunes page, and you can also tweet at me at Chris Chinch. You can go to my Medium blog and post comments on the post that accompanies this podcast, or you can also email me at chris@gregariousmammal.com. I'd love to hear from you and get an interesting follow-up post to this. So thanks very much.